So let's consider the case now when the wave speed c is allowed to vary with either time or space. So we'll replace this constant c with a wave speed that might be non-uniform or non-constant. All right, well, then we're going to be looking at an equation that looks like u sub t plus our new and improved c of xt times u sub x. And then this will be equal to some forcing function, which now might depend on xt or u itself. Okay, so the idea here is that we're going to use c given by x minus, actually, we're going to use c of xt, and we'll keep tau equal to t, and we'll figure out what c is supposed to be by looking for integral curves of dx dt equals c. Okay, so let's consider an example just to make this a little bit more explicit. So suppose 2t is our c function, and let's just keep it homogeneous for now. Okay, so we've got our wave speed there, our non-uniform wave speed, dx dt being equal to c of xt integrates to give us x equals t squared plus c, so that c equals x minus t squared. So, in other words, x minus t squared is a constant. And so if I'm traveling along the curve x minus t squared, that should be a constant for this function. And so that's telling us that we should take our c to be x minus t squared. Or in other words, x is going to be c plus t squared. And so if we plug this into our unknown function, then we'll have something that is constant along the characteristic curves that we need. So let's see how this works out now. If I have the time derivative of u by chain rule, that's going to be u xi xt plus u tau tau t, and so in this case, let's see, for the xi that we have, this is going to be minus 2t times u xi plus u tau, and then our u sub x is going to be by chain rule u xi x plus u tau tau x, and again that latter term is going to die, and xi of x is just 1, so this simplifies to u xi. Okay, so I can take these guys and put them back into my initial equation, and ut plus 2t ux becomes minus 2t u xi plus u tau, and then I've got the plus 2 times t times u sub x, which was just u xi, and this is supposed to be equal to 0, and I've got these guys canceling off, so that means I have u tau equals 0. And so now I can just go ahead and integrate that. So u is going to be some function of xi alone. And then if I put my coordinates in, I have that u of xt is some random function of x minus t squared. And that's my solution.